My name is Erick Erickson. I work for Lucid Imagination. I'm neither the handsome nor the knowledgeable Eric. That's this gentleman right here. So any technical questions, you can ask him. Talk here is a little bit about running Amazon on EC2. This is not going to be a deep technical talk. It's going to be more what kinds of things you can do on Amazon's AWS, Amazon's EC2. Who am I? Well, I work for Lucid Imagination. Solo Lucid committer. I do query performance and tuning. I've been around for a while. I started using Lucene some years ago on a genealogy project. And that's pretty much when I fell in love with open source. We were using a paid-for system, and I wrote an email trying to get some support. In the time it took me to get the email back telling me that I didn't have the right number, and so they couldn't talk to me until I gave them the right number, I'd found Lucene, downloaded it, loaded a bunch of our data, and started searching it. So needless to say, my company didn't use that anymore. I do other stuff. The important bit is right there. I sail. I noticed that Barcelona is kind of close to the ocean. So if anybody has a sailboat they need some help with this weekend, let me know after the lecture. I'll be more than happy to be your crew. Or if you know somebody who has a sailboat, please do. Okay, topics I'm going to cover. I'm going to go through some history, a little bit of scaling Solr. These two will be very brief. Most of you are really familiar with this part especially. We'll talk a little bit about running Solr on Amazon's on EC2 or AWS, scaling there, and then some of the possibilities that exist up there for not having to write your own infrastructure and having some real interesting sorts of scaling possibilities. And then, like any new technology, there are going to be some issues that you will be surprised at if you decide to start moving to the cloud. So the challenge I set for myself to try and prepare for this talk was largely to understand how Solr works in the cloud. And the short form is you just rent stuff up there. The stuff is a machine image, some sort of virtual machine running up there. You rent some storage, and you have there are a whole series of other resources and other services you can make use of that Amazon is more than willing to charge you for. I wanted to know what kinds of gremlins are out there, because any new technology has things that we're not familiar with and things that we have to learn to use. I wanted to know, the thing that we'd seen that was kind of exciting was the notion of dynamic scaling. And that's the idea that you can configure your system to automatically expand and contract to handle varying loads without you ever having to see it or ever having to know about it. That seems pretty exciting to a lot of people. And I wanted to see if understanding some of the tools and the limitations of those tools. Start with a bit of history. Professor Jarvis has a website that I took some of the images from with his permission a little bit later. And Professor Scott was one of my professors at the University of Michigan who is just a gentleman. And I have a quick story about what this particular guy was like. He had a bad hip, so he couldn't run. So instead of that, he would swim, which was perfectly reasonable. So I happened to run into him, and he was Professor Scott, not Dr. Scott. He did not like to be called doctor. So I ran into him in the locker room at one point, and I said, "Hello, Dr. Scott." "Excuse me, Professor Scott." He limps over to me and he says, "Eric, didn't anybody ever tell you when a man is not wearing his pants, he's not wearing his title?" And that's how I got permission to call him by his first name. The ancient history will lead to a relatively recent development called the data center in a box, and that's what has enabled the modern server farms. And these things are huge. So, a flip-flop, circa 1947 or so. This is a modern reproduction. It's even more advanced than the one that Professor Scott showed me, because that one had 7 tubes in a transformer. 14 watts of power, 1 flip-flop. Move into the 1960s. Things are getting much more modern, much more interesting. Professor Scott's lecture in I'm dating myself. That's about when I was in his class. We were amazed. 64,000 transistors on a 3x5 millimeter chip. And of course, Moore's law is giving us 1 million transistors per square millimeter in 2006. That led to, that kind of progression of technology led to Sun's development in the 2006 to 2008 timeframe of what they call a data center in a box. So the image you have here, these are these big shipping containers like go on cargo ships and are delivered by large trucks. So what you need to imagine is that this large truck pulls up into your parking lot and lifts off this large container and sets it down. You connect a big water, believe it or not, a water pipe to it because it's water cooled. You connect a power system and you connect a nice fat internet pipe, and you had, at the time, 250 servers running. Go back into your office inside, and you're up and going. Modern versions have, I admit, they're twice as big, they're twice as long, but they're up to 2,500 servers, almost 30 petabytes of storage, and you can just get them delivered. This is one of my favorite quotes about this development. This is the Sun's guy who was in charge of developing these things. He said he'd give lectures, and he would, he knew he was pushing the edge and that sort of thing, but this part in red is what he did not expect to hear. This speaks to how difficult it's been to expand capacity in a traditional bricks and mortar sort of data center. It takes, what, 2-3 years to build a data center from the ground up, and the requirement that we have more computing power of all sorts just made that process very difficult. So these got developed, and of course there are other companies who manufacture these now. And what that's led to, I have to apologize a little bit for the quality of this photograph, but Google is not particularly interested in having people take up-close photos of their massive data centers. But these things contain a whole bunch of those data centers in a box. You can kind of see down in here, if you look very, very closely, you can see the loading bays where the big trucks pull up to move things back and forth. These guys right here are cooling towers. There's the river in Oregon that provides the cooling water, quite literally, and they located it there not particularly for cooling water, but because up here somewhere is the hydroelectric dam that produces power that's pretty reliable for them. Schematically, this is what they think they look like. This guy is our data center in a box. It's a large view. These little guys are the trucks coming in. And these are the data centers in a box lining up in little rows that they plug in and plug out. Picture 400 of these guys times 2,500 servers sitting in a warehouse, basically, is what it amounts to. And you can see even up there, you can see the water towers that they're using for their reliable water supply to cool these things. I'm going to go really pretty briefly through these because I suspect most everybody here is quite familiar with it. But replication is how you use, is the preferred way of scaling Solr. You just have a complete copy of your index repeated n times to scale as high as you need. And then you go to sharding, which is when it's too big to fit on a single machine. You split a single physical logical index across several physical pieces. We pretty much know that. But this is the interesting question now. That's no longer as straightforward to answer as it used to be. We'll get to that in a few seconds, but the short form is that Amazon may have created a bigger image for you than you knew about when you sized your machine the first time. So when you start getting beyond the image that you use, you may be able to just say, okay, change one command line and be on enough bigger machine to keep your entire index on a single machine. It's a possibility. It's remarkable how fast this sort of stuff changes. So again, here's the basic diagrams that I'm sure you've all seen. Indexing master, 2 slaves, load balancer, requests coming in from the cloud. You repeat n numbers of slaves out here. Mostly I want to show you these slides so that we're all talking about using the same vocabulary. A sharded solution, 2 shards. We've all seen this one, I'm sure. That's half of your index. That's another half of your index. And these guys all know about each other so they can talk back and forth. And you can repeat this as many times as you need to, and within each shard you can repeat the server as many times as you need to. This is generally used for scaling very large installations. And then it's worth talking a little bit about the repeater setup because this is actually relevant to the Amazon system. The idea here is that this connection is expensive for some reason. I don't care what the reason is. It could be a slow data connection. It could be, in the case of Amazon, it could actually cost you to transfer data across that. So really what you have is a master up here who gets all of the indexing done. This guy acts as a slave. In other words, it pulls the deltas down from the primary to the secondary and then distributes them locally amongst the slaves that are asking it for index updates. So that's the background. And now we'll actually talk about Solr, how Solr lives up on the cloud. We'll talk a little bit of background about why it was developed by Amazon, what it really is. You need some things to make a machine run. You need what's called a machine image. Sometimes I'll use instance and I'll use them interchangeably, which is not quite technically correct, but it'll do. You need some storage. Once you've got all that, how does Solr actually run in that environment? What kinds of tools does Amazon provide for you to be able to manage whatever you have running up there? And the gotchas that I know about. Now, if you're really, really curious, one of my coworkers, Martin Koster, has some very, very deep knowledge on this subject, and I'll be glad to forward anything I don't know to him. Why was it developed? Well, Amazon had a problem, and their problem was they were growing very, very quickly. And the kind of bricks and mortar development of a data center was very difficult for them to actually do and keep up with their growth and with their traffic. So they developed this process whereby they could have a bunch of virtual machines out there. They developed a series of tools to manipulate them and to manage them. And then somebody had the bright idea. They said, hey, we've put all this effort. I wonder if we could charge other people to use it. And in another indication of how difficult it was and how these organizations really required more capacity than they could build conveniently, 18 months after they launched the commercial product, their customers' usage of their system was exceeded their own. So it just grew absolutely phenomenally. Okay, so I couldn't find the cartoon that I wanted, but you may all be familiar with the famous, I think it's a New Yorker cartoon, where there's two scientists are talking, a bunch of equations here, there's a bunch of equations over here, and there's this thing in the middle that says, a miracle occurs. And one of them says to the other, I think step 2 needs a little bit of work. You're starting to hear that same thing on the cloud. We'll just put it on the cloud, and everything will be fine. Well, not really. So I'm going to talk a little bit about what the miracle is. And the miracle is, they're really just virtual machines. Think of a VMware image. They're running somewhere on a hosted situation. They're backed by more or less permanent storage, which is one of the interesting things about the cloud is your storage, depending on what kind of storage you use, it may just go away. It may not. S3 is storage that's out there. It's backed up. Amazon makes some more interesting guarantees about how robust that data is, how many copies there are out there, whether it's physically distributed, a lot of other kinds of guarantees. EBS, or elastic block storage, a little bit more limited. It's faster. It's not guaranteed to be so robust. But you need some of that to make your machines run. You need some infrastructure to run these images. So remember those boxes that were going in and out of the data center? The very interesting thing about running things in the cloud is that your instance may go away, and may go away when you do not want it to. Amazon will bring another one up for you, perhaps, but the current one may simply disappear. All of that is rather simple conceptually. I mean, yeah, everybody can create a virtual image, everybody can run VMware to run it, but you don't have to develop it yourself. And that's I think one of the key points here. Your business is probably not running a data center. You're probably not selling to your customers the fact that you can create machines and you can assemble machines and you can tear down machines. So as simple as all of this seems, it's in reality, I think, very, very complex. And I'm just as happy that somebody else is willing to do it for me. To begin running on Amazon, you really only need 3 things. You need a machine image, you need some storage, and you probably need some scripting. The machine image is just the size of the machine. We'll talk a little bit more about that later. The storage, we already talked a little bit about S3 and elastic block storage. When you first start with the Amazon cloud, I recommend that you just start with their web-based interface. It lets you do the basic operations. Bring up an image, bring down an image, create a load balancer, attach some things. It's kind of limited. Anything you can do in the web interface, you can also do with the command line scripting that's allowed. We'll talk a little bit more about the command line interface and how that operates. So pretty soon after you start getting comfortable with images going up, images going down, you'll start wanting to script things rather than use the web interface. I'll tend to use an instance and a machine image interchangeably, but a machine image is really the template used to create an instance. You can create as many instances from a single template as you want. There are various sizes of them, and I'll show you a comparison in a couple of seconds. There are additional costs for storage and transfer. In particular, transfer across what they call zones. And there's a US West zone, there's a US East zone, there's a European zone, there's a Far Eastern zone, and I'm sure there are going to be others soon. A very interesting issue here is that the costs are constantly changing. Fortunately, they tend to be going down for the same computing capacity, but nonetheless, you can't just figure out what size of machine you're going to use that's optimal for your budget and then ignore it because it will change shortly. You can create your very own machine image I think the easiest thing to do is just to use one of the stock offerings from Amazon, modify it as you want, and then save it away. I'll come back to that in another couple seconds. But the stock images up there have various operating systems pre-installed. They have various software pre-installed, databases, all that kind of sort of thing. It's very easy to start with a configuration that contains the tools that you think you want. Change it a bit. Issue a single command, usually from the scripting line, and then save it away. And at that point, that image, when you restore an instance from it, will have whatever you installed on it ready to go. So what I did, for instance, was took an image, I installed Solr, saved that image away, and now when I run or create a running instance from that image, it has Solr already up and running when the thing comes up. Kind of a recommendation on the side. I doubt very many people will want to put the index on the machine image that they save. And the reason for that is that your index is going to be changing too rapidly. You'll either have to create a new image, which is a little bit painful, and do all of the bookkeeping to make sure that all of your next instances come up with that particular one, or implement some sort of replication on your newly instantiated image to bring it up to speed. And again, we'll go into that in a bit. First question. What's the best instance to use for Solr? Well, first understand what's available. There is a smaller than small instance called a micro instance, but I just skipped that one. I don't expect you to memorize the details here, but just understand that the capacity of these images varies pretty radically. 1.7 gigabytes to 68 gigabytes of memory. Much different local instance storage. Could be a 62 or a 32 or a 64-bit platform. And of course, Amazon is willing to charge you more for more capacity. So 8.5 cents US an hour to run this small instance, and $1.60 an hour to run this large instance. So the question immediately becomes, okay, and there are many other instance types and instance sizes, by the way. I just wanted to give you the kind of the small and the large range. So which one's best for Solr? Well, this is Lucid's patented response to most things about what is best for Solr. And it depends. There's a nice write-up in this at that website, and they'll be available electronically after this whole presentation will be available electronically after the conference here, so you can just copy it there. I think one of the more exciting things about this is that you no longer have the same kinds of constraints on testing things. So if you want to know what image is big enough for my particular Solr image so you can get away with it as inexpensively as possible, you can, once you have the test bed in place, spin up a new instance of a different size and see if it meets your needs. You can do that by varying one little part of one little command and then just run various scenarios to see how it actually works. There are machine images whose job it is to emphasize various resources, either disk access and disk speed, or CPU power, or cores, et cetera, et cetera. So you can test all of these things in various configurations and see what is best for your particular system. So we've talked about a machine image. Let's talk a little bit about storage. EBS, by the way, means elastic block storage. Elastic seems to be one of the buzzwords that Amazon wants to use. So S3 is permanent, it's secure, it's backed up, it's distributed, it's physically reproduced in various places. So it's really it's Amazon's pretty safe, secure, robust data sources, or data storage disk sorts of beasts. You can use it as the basis for an EBS volume. So that gives you the opportunity to go ahead and create an index on your EBS storage, periodically take a snapshot of it to the S3 storage, and use that as the basis for new images that come up. So that's one way to kind of reduce the replication time that you might have to worry about otherwise. Elastic block storage, on the other hand, is, and S3 can be accessed. Think of it as a kind of a networked file system. The EBS storage is only accessible by a single instance, so you can't have two instances looking at the same EBS, elastic block storage. You can kind of think of it as a mount point in a Unix system. And then there's what I was saying about taking a snapshot of the master, which is actually a pretty inexpensive operation. And then one of the gotchas that you will find really exciting as you work with this is that EBS data is not necessarily going to be there when you bring your machine back up again. You have control over that, but it's a little surprising to have your data just disappear. And there's some more we'll talk about a lot of things that can disappear when you're working on in the cloud. And then there's ephemeral storage, which is a level less reproduced and less secure than even the EBS storage. It simply goes away when the instance dies. It's gone. Forget about it. It's closer to the metal, therefore it'll be faster, and it might be the right place to put your slave indexes. You'll see when I talk a little bit about how the steps I go through to bring up an image, why this might be a viable option. As I mentioned before, Amazon provides a set of APIs for carrying out most anything you want to. The GUI, the web-based GUI, lets you do some elementary monitoring, lets you do some elementary manipulation of your images. It's a fine place to start because like all command line manuals, the APIs go on forever, and you have no idea which one you want to use first. So that will get you started so you can actually see an image. The way this works is there's a set of libraries that you download and put on your local laptop somewhere. So now you're sitting in a command line on your laptop and you execute this query. It knows where you're operating on the cloud, an Amazon system, and it actually executes the command up there remotely. Here's the base where you can start looking at all the references. And these commands are what you'd use for your scripting process for any of your autoscaling that you want to try and do. A little tricky bit. The commands are in different packages that you download. And of course, ELB is the Elastic Load Balancer. So if you want to create your own load balancer, it's in a little different library, a little different download than if you want to create a machine instance. So it takes a little bit of time to start wending your way through all of the tools that are allowed and know where they are and know where you have to go to execute them. It's not complicated, but it is also not entirely obvious the first time you're working with it. This is what a pair of commands look like. Again, I don't present these with the intent that you memorize them. I just want to get a flavor of how they work. So this is starting up a machine image. This is creating an instance from an image. That's the image that I'm using, M1 large. Some credentials you have some local credentials that you have to be able to present to Amazon to be able to manipulate your installation. That's the base image that I'm using. So this might be something that I've created and saved. And that's the size machine I'm running it on. And that's kind of what I was indicating earlier, that you can go ahead, you can say, I want a super duper extra large one. And I can just change that and be running on a super duper extra large one. Next command is creating a load balancer. Give it a name, tell it where it's operating, some other information. Again, don't worry about it too much. That's just the flavor of the commands that you'd use to either start things from your desktop or to script something. Okay, so you figured out how to start machines. You figured out how to maybe even create a load balancer, all kinds of interesting stuff. What do you do to actually run Solr up on EC2? I was talking a little to Uwe on the way out, and he said, well, you just start a virtual machine, you put Solr on it, and you're running, right? And he's right. It just works. Once you have the machine up there, you can execute commands remotely, you can upload programs to it, or you can in fact download the Solr from the web right straight to your image, unzip it, install it just like you would any other image, and be up and running. That can happen once you've done that for a while, or once you've done it a couple times and stop being afraid of it. You can do that in just a couple minutes, maybe 5 minutes. You can have an installation running with Solr. You could then configure it however you wanted to. Save it off as your own private image that you can then recreate whenever you need to. You can create scripts to handle load, and we'll expand on that more, but the idea here is that one of the possibilities and the things that some of our clients have been really interested in is the notion that they no longer have to maintain useless capacity. So if you imagine an e-commerce site, you imagine, in the US at least, the 2 months of November and December are when merchants do almost all of their business. I think in the order of 60, 70% of their business or more is done during those 2 months. The other 10 months of the year, if they're going to handle that capacity, the other 10 months of the year, that capacity is sitting idle. That's a huge waste for them. They could consider just bringing up some instances November 1st, letting them run for a couple months, shutting them down and throwing them away. You can do that on an even more dynamic pattern, and we'll talk a little bit about CloudWatch later, which can create a situation in which you have very few situations where your users actually experience slowdowns in visiting your site and doing their searches. The limits of what you can do and you want to do are really limited mostly by your imagination and by what your requirements are. I can imagine a situation where I have lots and lots and lots of data. It's static. The right solution could well be to go ahead and index it all locally, have the entire thing sitting where I am, just transfer the index up, and then reproduce it on as many machines as I want to handle the searching. It's up to your situation. It's up to your business to decide what's the optimal for your budget, which is really what this is all about, right? If you had an unlimited budget, you would hire somebody to build you the biggest building in the world, and you'd populate it with all the servers and all of the best networking people you could and not worry about it. So this is really all about how to save money. So really all you're doing is treating EC2 as a convenient place to run Solr, pretending it's really down the basement or across the street in your more usual data center, and you're just running it up there. The interesting part about this to me is that all of our corporate accountants are trying to make sure that we don't have a lot of unused capacity laying around. Therefore, we're trying to run the servers, our own servers and our own farms, utilize them as much as possible. So what happens if our application is actually the most popular thing since Facebook or Twitter, and use actually just starts to explode? Then we can start scaling up on the web or up on the cloud without having to invest much of anything at all except a few minutes worth of configuration. If you're scaling wide in the Solr case, you simply bring up your instances, you register it with the Elastic Load Balancer, and optionally you can use something called CloudWatch, another tool from Amazon, to tell you when you're about to run into trouble. So what this looks like, this is very close to the other diagram I showed. You've got a master, you've got a pair of slaves, they're replicating from the master. There's an electronic load balancer that's servicing incoming requests, and now you've detected for one reason or another that your demand is increasing. You simply go up, spin up an on-demand instance, wait for it to replicate, register it with the load balancer, and you now have some more capacity. That whole process, bringing up the Solr instance, is probably a couple of minutes of time. The replication, of course, depends on how much data you're moving, but the point is it's very, very short. It's way shorter than requisitioning another machine, getting it in, provisioning it, and all that kind of thing in your own institution. Scaling deep. There's not a lot more about this than you saw with the scaling wide. It's just a little bit more complicated because your topology is a little bit different. As I mentioned before, though, the necessity of scaling deep the decision to do that is made more complicated by Amazon, because you might be able just to change the size of your hardware, use a different AMI. That one command I showed you, M1 large could be M1 super large, and you could be done and not need to scale deep. And this is the thing that's driving me a little crazy, is even if you're using the largest AMI available, next month you may have a bigger one to choose from. So you have to kind of keep track of what the most recent piece of technology Amazon is offering is. And this is what that looks like. You could replicate across these shards X, Y, and Z. There's no reason that you have to have the same number of slaves under each shard. You can tune this to run just as many of those as you need and no more. With CloudWatch and Autoscaling, that question becomes easier to answer because you don't have to answer it up front. So AWS, Amazon provides a series of tools for managing your installation. There are other ones that are important, but these are the ones that I think are, the first two are things you absolutely need to get started, and the third is something you probably want to consider pretty quickly into your adventure. we talked, the elastic load balancer is probably pretty straightforward. You have an idea of what that is. So let's talk instead a little bit about CloudWatch. I put CloudWatch as a trigger for spinning up another instance. It's really better phrased as a way to get alerts when various things happen to in your installation. If I script new instances, I'm recommending that you script a new instance from the perspective that if I get an alert from CloudWatch, I want to be able to have my next machine up and running as quickly as possible. I'd rather enter just one command than a bunch of them. Some recent changes in the Amazon's interface allow you to register something with a load balancer later after it came up, specifically after replication and warm-up in Solr. Two easy approaches for when to register with the elastic load balancer are timed. You just kind of know. You've timed a few times how long it takes to bring up an instance, replicate your index, have auto warming happen, and you just wait till that time has passed before you register things. The key about registration is as soon as you register your instance with the load balancer, it starts servicing requests from your users. So you want all your prep work done before you do the registration. A little more sophisticated way of doing that would be to use some of the Solr HTTP commands on your new instance to know when the index on your slave had the same revision as the index on your master, and then do the registration. But that's kind of one of those implementation details. Starting here, you've got the scripts ready, you've got CloudWatch sending you alerts. This is kind of presupposing a manual process. In other words, your operating system people get a message at 3 o'clock in the morning saying you're about to run out of capacity. It's better than having your users have a poor experience, but it could be better. One of the ways that gets better is by autoscaling. The notion here is that CloudWatch can give you alerts based on certain metrics. So queries per second, CPU load, latency of response. You can create custom alerts. So there are situations that you particularly want to know about that are not terribly generic. And instead of sending a note to your operations people, you can instead use those alerts to automatically start up an instance and increase your capacity. So you imagine that the alert comes down to your system. It says, okay, in that situation, I know I need to spin up another instance, register with this particular load balancer when it's all done, and then so you can have all of this happen without human intervention at all. Especially for e-commerce sites, this could be a really powerful feature in that you run the sale. The sale is going to happen, and it's only going to happen between midnight and at midnight the next day, and all of a sudden at 12:01 p.m., 500,000 people sign onto your system and want to buy your product. Well, it could just be handled. It also, curiously enough, you need to go the other direction, because remember that instances are rented to you by the hour. So as soon as your utilization drops below some particular level, CloudWatch can not only alert you, it can also automatically remove instances from your system, and so you stop having to pay for them. A little note is that Amazon charges by the hour or fraction thereof, so there's no reason for shutting down an image until 59 minutes have passed. Dynamic load balancers are what you would imagine. They just make things, distribute requests amongst whatever machines are registered for them. You need to script. I would expect that you would want to script the registration process. I don't have a really good answer for how you know how long replication will take, because remember, this is a virtual image, a virtual machine. It's a little bit away from the metal. Your response times are going to show a greater variance, and your read and write times will show a greater variance. But you can at least you can know when the replication has been done. And you want to also be sure to include your warm-up times. This is the typical Solr auto warm time that you want to have, that you want to elapse before you actually start serving queries. It's certainly a question that people have right off the bat. You're giving it all to Amazon, right? So how do I trust Amazon? Well, that's a really good question. I don't know a really good answer. They'll offer a virtual private cloud, which is they make additional security guarantees, and they charge you for it. The quote from one of the Amazon manuals, if you're really, really, really worried about your data, you want to encrypt the data on the disk so that nobody else can find it, even if or decrypt it, they'll say, okay, put an encrypting file system on top of EBS, you'll be fine. We've seen people who will want to encrypt their data, actually in the index. So you can encrypt the data, you can actually search it. That has a couple of problems. A number of Solr features will not work well on encrypted data, particularly things like fuzzy queries, things like prefix queries, wildcard queries. If your encrypting algorithm is good at all, two words with different endings will not encrypt to the same beginning. You can't really do wildcards. But we have some people who want to do that. We have some people who have encrypted the stored data out there, but not encrypted the data in the index. I don't know how sensitive your data is. You can just trust Amazon. I think there should be a trademark code there too. You can also decide that nobody's really going to be able to eavesdrop on your data if you just encrypt the communications protocol. Whoa. And this is kind of a side note here. Amazon also has a series of what they call security groups. Those are not intended for end users. Those are intended for people who belong to your organization. It's just like sysadmin, sysops privileges, that sort of thing. Some gotchas. My colleague Martin blogged about this particular one. Everything can come and go. That's kind of the primary thing you have to understand about the cloud, including IP addresses. So you can have an ill-behaved client out there who gets somebody's IP address from an application totally unrelated to yours and holds on to it. That person's application goes away. You spin up some more instances, you could get assigned that IP address, and all of a sudden start receiving information from a completely different application. Latency, you have to be a little careful about this because you can't register something with the elastic load balancer prior to it being ready to serve requests very quickly. The costs are always changing, and fortunately for us, they've been changing and getting cheaper. So data transfer costs. You're not really accustomed, I don't think, to thinking about being charged for data transfer. Data transfer within your own data center is essentially free. And it may not be infinitely fast, but you can move as much of it as you want. Not so. If you go across availability zones, sometimes called regions, et cetera, and out of EC2, you'll incur a charge. That could probably mount up quite quickly. Your machine instances, the costs vary by the capability. Absolutely have to test this. This is that URL that I referenced earlier. These are virtual machines. Lucid had a rule of thumb for quite a while that we see 10 to 15% performance penalty operating Solr on a virtual machine. I'm not going to guarantee that's the same thing that happens on Amazon, but it might. This is interesting, to me at least. Instances can just go away. So Netflix wrote about their Chaos Monkey. They wrote an application whose exclusive job was to run around all of their instances, all of their processes, and kill things at random so that the rest of their application would be robust enough to be able to actually handle it. Fortunately, Solr is a little bit more self-contained, so you generally don't depend on a lot of other things being there, but things can go away. You have to get stuff up to EC2 and back in order to index it. If you're indexing petabytes of data, that may take an awfully long time. You're trusting Amazon. They could pull the plug. The security setup takes a little getting used to. Fortunately, you have to do it once. Unfortunately, once you've done it, you'll forget what you did. So but they have to have a security setup to allow people controlled access to your instance, to your setup. It's kind of hard. At some threshold, EC2 will cost you more than hosting it locally. You won't know until you test. You absolutely will have to allocate time and budget to establish in-house expertise on this technology. Like everything else, it seems easy, but it's not necessarily. It's way easier than doing it all yourself, but nonetheless, don't forget to allocate some time. All that said, I find this pretty exciting. You can be up and running very, very rapidly. You can experiment very, very rapidly. You could think about using EC2 to do lots of CPU intensive work and then bring it back home. You can scale quickly, and again, your business is probably not running a data center. The most important point here is that if you're a startup, you can actually start up and do things without having to invest in a data center. So you can very cheaply get started, discover your idea is the greatest thing since sliced bread, and you're going to all be billionaires, or discover it was a really dumb idea and fail cheaply, at least. All right, almost done. I have to whimper on the way out. The nature of this kind of talk means I can't do much more than kind of scratch the surface of EC2. But I've been around long enough that I really kind of miss the old days. For all of you old enough to remember the Kernahan and Richie, the C programming language, right? All 220 pages of it that you could completely memorize and know everything you needed to know about programming. My bookshelf at this point is about yay long, and I've gotten through about 5% of it. I'm saddened to say that Richie recently passed away. He's died earlier this month. Essentially, one of the founders and enablers of the modern computing system is no longer with us, and we will miss him. My other whimper is, okay, you want to move to the cloud. It works great. Everything is wonderful. But you'll need somebody whose sole job is to keep track of how fast things change. I'm exaggerating a little bit there, but nonetheless, you can no longer count on a static system that doesn't change very rapidly. It's changing extremely rapidly. Oh, let's see. I think this is actually a great technology. I think it's got some wonderful possibilities. It has its own gotchas, however. It has its own places where it's going to fail, where it's going to not be as, where your reflexes and your habits will play you false. You're accustomed to thinking, for instance, that your disks are always there. They may be, they may not be. You're accustomed to thinking that something catastrophic has had to happen for your machine to just quit. That's no longer true. It can just disappear out from underneath you. So, like any new technology, it has its own characteristics, and you have to allocate some time and energy to figure out what those are and how you're going to cope with them. Therefore, you really have to expect to take some time and go through some expense to build up the in-house expertise. Thank you all. I'm not going to go through these too much. But Professor Jarvis has some very interesting pictures of old technology for all you young kids out there who don't know what a flip-flop is. This is a recent change to elastic load balancers that allow you to register instances with them when you want rather than when the machine comes up, which I think is going to be critical. Of course, Lucid Imagination is there. Send us email if you want to know things, or if you want to ask us questions, and we'll try to answer them. Amazon homepage, the APIs are there. This is the link I've referenced a couple times about I/O benchmarks did I say I/O benchmarks? Okay, wrong label there. That's performing some benchmarks on Solr on the cloud and talking about what image is the best for you. And last, and I hope probably least, is you can get in touch with me there if you have questions. I do have a few cards, so I'll pass them out if anybody's interested. 15 seconds to spare. And that's it.
You mentioned that the ELB storage instances can just go away. Mm-hmm. What do you mean by that exactly?
Okay. The question was, I said that ELB storage can go away. There are certain varieties of EBS storage, pardon me, that when you turn off your machine instance, did I?
No, keep talking. No, you're still on.
Okay. When you turn off your machine instance, the instance will, whatever you wrote to disk will just be gone. You can't get it back. Okay. But you can control it. Don't get me wrong there, but it's something you have to kind of be aware of in the back of your mind. And in fact, the first time I tried to create a machine image with 414 gigabytes of attached storage, the script that I wrote was slightly wrong. And when it came back up, I had the disk mounted. Unfortunately, it only had 8 gigabytes of storage. So there's some things like that that you'll find exciting.
You mentioned indexing speeds limited by the basically uploading your data to EC2.
I'm sorry, by what?
You mentioned indexing speed is limited by the connectivity between yourself and EC2. Surely that isn't the case if you're crawling, for example, with a crawler actually based on EC2.
Oh, yeah. My comment was mostly that if you're indexing something and you have lots and lots and lots and lots of data, you have to get it to EC2 in the first place before EC2 can operate on it.
Fine, yeah.
Don't know, that could take forever.
Okay.
So you just have to understand that your network latency is probably greater than you're accustomed to when you start planning those sorts of things.
So you mentioned that you use HTTPS to communicate with the services. Where would you terminate that? Is that something you terminate on the elastic load balancers? Or would you go that all the way through to Solr?
No, what I'm saying is anytime you're communicating, particularly when you're sending data up to Amazon, you may want to use some sort of secure layer. I don't care whether it's HTTPS or SSL or whatever, but that's only if you're really worried about somebody eavesdropping on the data transfer. And that really depends on how sensitive you think your data is. If you're an organization that crawls public websites and indexes it and serves up search, you probably don't care much. If you're a medical information company, if you're a financial institution, you care very much. And that may be a reason to take greater precautions when you actually communicate from your institution to Amazon and back. So I think we're done.
Thanks very much.